Okay, so now we're in chapter 8.1 and we're going to be looking at the introduction to variables. A combination of numbers, letters, and operation symbols is called an algebraic expression or simply an expression. We have the following examples: 3 plus x, 5y, and then 2z minus 1 plus x. These are all expressions. When we replace a variable in an expression by a number and then find the value of the expression, we call this evaluating the expression. So the key word here is evaluating. And in order to evaluate, the first thing you're going to do is replace the variable in your expression with a value or a number. So this is what we call plug-in. In the problem, they'll tell you x equals 5. So everywhere you see an x in your expression, you would make it 5. So let's pretend for a moment that I had x as 5. And then for this first example, it's going to become 3 plus 5, which is 8. So let's go in our books to page 565 and we'll look at the following problems, starting with number 1. And it says evaluate each expression when x is negative 2, y is 5, and z is negative 3. And for number 1, we have 3 plus 2z. So the first thing we're going to do is replace the z. And we'll keep everything else the same. So we'll have 3 plus 2 times negative 3. And then we're going to work this out. So 3 plus 2 times negative 3, that's the same as saying 3 plus negative 6, which is negative 3. And then number 7. Now we have 3x minus z. And again, we're going to start by replacing our letters. So it's going to become 3 times x, which is negative 2, minus z, which is negative 3. So 3 times negative 2 is negative 6, minus negative 3. We know a negative and a negative makes both of these positive. So negative 6 plus 3, which is, again, negative 3. And then number 9, we have 8 minus 5y minus 7. So we'll start by replacing the y. So that's going to give us 8 minus 5 times 5 minus 7. So that's 8 minus 25 minus 7. And then remember, we work inside the parentheses first, so we have 8 minus 18. And then 8 minus 18, well, that's negative 10. And then number 11, we have y to the third power minus 4x. So again, replacing the x and the y. Well, y is 5, so that's going to become 5 to the third power minus 4 times negative 2. And 5 to the third power, that's like saying 5 times itself 3 times, so that's 125. And then negative 4 times negative 2 makes it a positive 8. And we come out with 133. And then last one, number 17. We have x plus 2y divided by 2z. And we'll start by replacing the x, the y, and the z. So x is negative 2 plus 2 times 5, all divided by 2 times negative 3. And if you're using a calculator, you can just type this in with your fraction command. If you're doing it by hand, we'll start with the 2 times 5. So that makes it negative 2 plus 10 divided by negative 6. And then negative 2 plus 10, well, that's positive 8 over negative 6. And we can simplify this to be negative 4 over 3. The addends in an algebraic expressions are called the terms of the expression. So in the following example, we have 5x plus 3 equals 2. Here we actually have an equation. The terms are the parts of your expression that are separated by the plus sign or the minus sign. So we have a 5x, and then we have 3. So we have two terms, and they're 5x, and it's 3. A term that is only a number has a special name is called a constant term. So back to our example, we had 3. This will be our constant term. And then a term that contains a variable is a variable term. Well, 5x contains the variable, so that is our variable term. And then the number factor of a variable is called the numerical coefficient. So if I go back to my variable term, which is the 5x, the number factor of it is the 5. So this would be the coefficient. So the coefficient here is 5. The variable term is 5x, and the constant term is 3. When we're combining like terms are terms that have the same variable. So for example, 3x and 1/2 x. Both of these terms have an x, therefore they are like terms. The next example is negative 6y, 2y, and y. Again, all three terms have a y, therefore these are like terms. Unlike terms, for example 5x and 5x squared, even though both contain an x, they're not raised to the same power or exponent. This has an exponent of 2, and 5x has an exponent of 1. Therefore, they're not like terms. The next one is 7x and 7y. Again, these aren't like terms because the first one has an x and the second one has a y. So again, like terms are like terms are terms that have the same variable raised to the same power. So in our books on page 566, we're going to start by looking at number 25. It says simplify each expression by combining like terms. So number 25, we have 3x plus 5x. Well, these are like terms, which means we're going to keep the x and we're going to add the coefficients together. So keep the x and add the coefficients together. So 3 plus 5 is 8. So our final answer is going to be 8x. And then number 29, we have 4c plus c minus 7c. Again, we have all like terms. Each term has a c, so we're going to combine the coefficients. So the first coefficient is 4. The second one is invisible, which means it's the 1. And then the third one is negative 7. So 4 plus 1, that is 5. Minus 7 is negative 2. And then don't forget the c. So this is negative 2c. And then number 33, we have 4a plus 3a plus 6a minus 8. So this time we're going to start with our a's. So we have 4a plus 3a plus 6a. These are all like terms. So we're going to add the numbers together. So 4 plus 3 is 7, plus 6 is 13. And we make sure to keep the a, so we have 13a. And then this minus 8 is by itself, so we're just going to attach it at the end. So our final answer is 13a minus 8. And then number 35. We have 1.7x plus 3.4 minus 2.6x plus 7.8. So let's start with the x's. We have 1.7x minus 2.6x. Don't forget to take the sign along with you. These are like terms because both of them have an x. So we're going to do 1.7 minus 2.6, and we should get negative 0.9, and then don't forget the x. And then our constant terms are 3.4 plus 7.8. So 3.4 plus 7.8 We add those together and we get 11.2. So the final answer is negative 0.9x plus 11.2. And then the distributive property. So the distributive property says that if you have a parentheses with an expression on the inside, and I have a number on the outside of my parentheses, so for example, they called it C, let me call it 3, so I actually make up a number. The distributive property says you're going to multiply each term inside the expression by the number on the outside, and that's what we call distributing. So for their example, they had C on the outside, that represented their number, so they're going to multiply each term on the inside by C, so A times C, that's how they got AC, and then plus, and then B times C, and that's how they got BC. You can do the same if you're subtracting on the inside, so again A times C is AC, and then minus B times C, which is BC. So again, in our books on page 566, we're going to look at problems 63, 67, and 69. We'll start with number 63. It says simplify each expression. Use the distributive property to remove parentheses first. And for number 63, we have 2 times parentheses x plus 4 minus 17. And that equals. So the first thing we're going to do is we're going to start with the number on the outside of the parentheses. This is the distributive property. We're going to multiply it on the inside. So 2 times x, well, that gives us 2x. And then 2 times positive 4 gives us positive 8. So we're going to say plus 8. And then don't forget to write the minus 17. So the first step is to distribute. Now the next thing we want to do is combine our like terms. So we have 2x. And then 8 minus 17 is minus 9. So 2x minus 9 is the final answer. And then number 67, we have 3 plus 6 times w plus 2 plus w. Again, whenever you see parentheses, you start with the parentheses first. So we're going to distribute first before combining any like terms. So everything on the inside of my parentheses can be multiplied by the 6. So 6 times w, well, that's 6w. And then 6 times positive 2, well, that's plus 12. Don't forget to write down the rest of the problem. So I still have 3 plus 6w plus 12 plus w. Now starting with the w's, let's combine our like terms. So 6w plus w, remember the invisible 1 is here. We add the numbers and keep the w, so that makes it 7w. And then 3 plus 12 is 15. So we have 7w plus 15, and that's the final answer. Now how do we know this is the final answer? Because when we look at 7w and 15, these are not like terms, therefore I cannot combine them, and I leave my answer as it is. And then last one, number 69, we have negative 2 times parentheses 3x plus 1 minus 5 times parentheses x minus 2. Again, when we see parentheses, we start there, so we're going to distribute first. So for the first set of first parentheses, we're going to multiply the negative 2 on the inside. So negative 2 times 3x is negative 6x. Negative 2 times 1 is minus 2. And then for the second parentheses, we're going to multiply the negative 5 on the inside. So negative 5 times x, well, that's negative 5x, or you can write as minus 5x. And then negative 5 times negative 2, well, that's plus 10. Be careful of your signs. Remember, a negative times a negative gives you a positive. Now we combine our like terms. So negative 6x minus 5x. Negative 6 minus 5 makes it a negative 11. Don't forget to keep the x. And then negative 2 plus 10, well, that's plus 8. And then we see our final answer is negative 11x plus 8. These are not like terms, therefore I leave it as I see it. Alright, so this will conclude our video for 8.1. Please email me if you have any questions.